Hello everyone, today let's talk about project motion. What is project motion? A body which inflates through the atmosphere but not be propelled by any fluid is called project motion. There are three common types of project motion: vertical project motion, horizontal project motion, oblique project motion. When you throw vertically upward an object, so from here to here is height. When height is maxima, the velocity is 0. So when higher is 0, the velocity is maxima. When the object is up, the velocity is decreased. When the object is down, but the velocity is increased. We can from equation of accelerated motion to get the equation of vertical motion. We just need to change the S to H, A to G. The G always equal to 10. The horizontal project motion. Because of the friction, so the horizontal project motion makes horizontal motion and the vertical motion at the same time. So in the horizontal project motion, we can get two vertical and two distance. The horizontal motion is a uniform motion. Horizontal vertical after any time is same, so the Vx equal to U. So we can from equation x s equal to vt to get the horizontal distance x equal to ut, or x equal to vxt. A vertical motion is a uniformly accelerated motion. The initial vertical velocity is 0, so the u equal to 0. Finally, we can from equation of accelerated motion to get the equation of the velocity motion. We need to change s to y and u equal to 0, so we can cancel the u. Because of we have two velocities, so the velocity of the object is v equal to square root of vx squared plus vy squared. The oblique project motion. When you throw obliquely upward object, we can get an angle theta. This motion same as the horizontal project motion. So because of the friction, the oblique project motion makes the horizontal motion and the vertical motion at the same time. And then we can use this angle to get the initial vertical of the velocity motion and the horizontal motion. The horizontal motion is a uniform motion. The horizontal velocity is equal to ux equal to u cos theta. The horizontal distance equal to vxt. The vertical motion is a uniformly accelerated motion. The initial vertical velocity is uy equal to u sin theta. Finally, we need to remember these three different equations.
It's about how to get the time of flight, horizontal range, maximum height.
Hello, today I'm going to present about universal gravitation. So, it states that every particle in the universe attracts every other particle with a force that is directly proportional to their masses and inversely proportional to the square of the distance between them. So in this diagram, it's telling that the force that mass 1 exerts on the mass 2 is equal and opposite to that force mass 2 exerts on mass 1. And then we'll look for the formula. So it states that Fg equal G multiplied by mass 1 and mass 2 divided by R squared. So Fg is gravitational force, R is distance between their center, or you just call radius. And for the G is gravitational constant, and this is the value of it. So the next one is about gravitational field strength. It can be defined by these two formula. So the first one is gravitational on Earth is equal G constant multiplied by the mass of the Earth and divided by the radius of the Earth square. We use this formula on the Earth's surface from here. And then the second one is the gravity on Earth equal G constant multiplied by the mass of the Earth and then divided by the radius of the Earth plus its height square. So it is different from the first one because we use this above the Earth's surface. As the picture on here, you can see that it has a height from here above the Earth, so we use this and put it in a formula to make it okay. So the next one is about orbital velocity. The orbital velocity is the velocity in the orbit that given to the body to keep in orbit. So for example, if the moon is rotating the Earth in a circular motion, and we can see that it has velocity in the circular, and we can see that it has a radius or a distance between from the Earth from the moon. And then we create the formula like this. So the velocity in orbit, or V orbital, is equal to the root of G constant multiplied by the mass divided by the radius or the distance plus its height. And also the V orbital can be expressed in the other way too. Like this formula is the V orbital is equal to the 2 pi r over the period. And you can see that dr can be expressed to the radius plus h over the period. And the t is the period of the rotation of the moon or the satellite that rotate the planet. So for the last one is about the other's formula. So first one is geosynchronous satellite. If the period is involving, or the question is asking about or talking about the revolution, the period, you can use this formula. So you can find the radius, you can find the period, you can find the height. So this formula is the radius, any radius is equal to the cube root g constant multiplied by the mass and the period square, and then divided by 2 pi square. And if it has a height, or it's asking for the height, make sure you use minus height 2. And for the second one and the last one, if the centripetal acceleration is occur, we can use this. It's defined that the acceleration is equal to the velocity square defined by the radius plus its height. So thank you so much for the presentation.
Hello, my name is First. Today I'm going to talk about circular motion. So circular motion is different from the other motion that we have been learning so far, because we are going to use a new variety of a equation from the linear equation and vertical equation, and also the angular equation too. So this type of equation is often used to calculate the motion of the planet and a wide variety of earthbound objects. So, example, like consider the Ferris wheel as a circular motion because it inhabits a single axis point that go to the center of the Ferris wheel. So because it's a circular motion, the radius from the center to the edge of the circle is constant, so it doesn't change whenever it is. And now we are going to talk about the tangential speed. So the tangential speed is a speed that keeps the car going in the straight line. We have something that is called the tangential speed line. That depends on where the car is on the circle. So it will be different from the line is different if it is on the other position of the line. The first video, like if this one, it's going to be like this one. But now, if the tangential speed is constant, it is what we call uniform circular motion instead. So now let's talk about something that is weird about a circular motion. So if we have a car here, but there is the other car that is closer to the center of the circle than this one. But for some reason, if the car complete the circle at the same time, with the same time that this car completes the circle. So the B car cover less distance from the A car. So the equation of the speed is going to be speed equal direction over time. So if the direction is shorter, so the speed is going to be the tangential speed is going to be shorter too, but it still have the same time. So this is kind of confusing, but it's going to make sense if we involve a angular velocity to come into. But we are going to talk about that in other day, not this one. This is circular motion view. Next one. Now let's continue. So the uniform circular motion happen because the constant centripetal acceleration. At any given time, the velocity is tangential to the view of the hemisphere. So the magnitude of the height will always be the same. So if you not same, so it's constant. But the dimension of the car where the car is moving is constantly changing due to the circular motion. So any research giving change of the velocity that happen to the car is due to the changing of the centripetal acceleration. So the centripetal acceleration is the force that keep pulling the car back to the center. So this combined with the tangential speed is what makes it a circular motion. Now we are going to talk about the equation that uses this. Let's talk about centripetal force. So this is the equation that we are going to use. Its force, the center force is equal mass times velocity over like this. So the meaning of this is that if we have a smaller radius, the force is going to increase. So if the object is near the center of the circle, the force that we are going to use this will be increased. So now let's do some exercise or some example if you have a figure which you won't because I don't know to send this. So let's imagine the stone. This stone is 2 kilograms. So the mass is 2 kilograms. And it is attached to a 5-meter thing, and it is swing with the speed of speed of 25 meters per second. So the velocity is going to be 25. Now, if there is something, if a question here, so now let's calculate this. So the force, the centripetal force that is used during swinging the 2 kilogram stone with 5-meter long sling using 25 meter per second speed is 2. Teacher, I am going to say I am really sorry about this presentation because I'm not good with this. At least I try. Okay? At least I try. Thank you very much.